In this video, we will be looking at homogeneous equations. So in the last video, we looked at separable equations where we were easily able to separate the variables and directly integrate. But there's cases where you cannot easily separate the equation, and you have to make a substitution to do so, and that's called a homogeneous equation when it's in this form. So let me just start off with an example. So example 1, we're given dy dx is equal to y minus 4x over x minus y. Now you'll notice, if you notice, think of these as the quantity. If you multiply both sides by x minus y, you'll be left with, let's look at this. We'll be left with x minus y dy. No matter what we try to do here, we cannot separate it. We'll always be left with an x with a dy and a y with a dx. We don't want that. It's not separable. Now because it's not separable, we need to check if it's homogeneous. So if it's homogeneous, basically it means that the right side of the expression can be expressed as a function of the ratio y over x. So what this means is, can we do like an algebra trick on the right side to get it in terms of y over x, to get the numerator and the denominator in terms of y over x only? So let's check. Can we do that? Well, what I'm going to do to get the numerator and the denominator in terms of y over x, for the numerator, if we look at this, we have y minus 4x. If I divide by x, it'll cancel out the x in the second term, and it'll leave us with y over x for the first term. So then we'll be left with y over x minus 4. We don't need the parentheses. Over, for the bottom, we do the same thing. We divide by x, because that would leave us with 1 minus y over x. See how I did that? So now we have a y over x only in our numerator, and same for our denominator. This is what we want. So yes, it is homogeneous. We have a homogeneous equation here. So now, to make it separable, all we did was rewrite it. This is the exact same thing that we had before. All we did was an algebra trick to rewrite it. And if it is able to be rewritten in this form, it's homogeneous, which it is. So now we're going to do a u sub. So to make it separable, we're going to do a u sub. We always, for every case of a homogeneous equation, you're always going to set u equal to y over x. This is our substitution. So we can already see that we're going to plug y in for the y over x's. So we will be left with u minus 4 over 1 minus u, right? Just one issue. We have this term here. So if you see here, this equation here, I'm going to rewrite this over here. We're going to have y equals u times x. This allows us to solve for dy dx. So now we can solve for y prime, or dy dx is equal to, you have to do the product rule, right? So first times the derivative of the second, that's u times the derivative of the second, this is just 1, u times 1, plus the second times the derivative of the first is du dx. Right? Okay, so now that we have our dy dx, well, that doesn't look like a u. Hold on. Du dx. Okay, so now that we have our dy dx, we can now plug it in. So now we'll have u plus x du dx is equal to u minus 4 over 1 minus u, right? And now we need to solve for now we have a separable equation basically, but we just have to simplify it. So now we can subtract the u over, so we have x du dx is equal to u minus 4 over 1 minus u minus u. So this will become x du dx is equal to, so to simplify this, we're going to do u minus 4 minus u times 1 minus u over 1 minus u, right? That's how we can get a common denominator for the u. We multiply it by 1 minus u, and that'll leave us with this. Actually, let me to make this a little more clear, right? More algebra tricks. So you'll notice that diffie-q is a lot of algebra and a lot of algebra tricks. Especially as we go forward, a lot more tricks are going to happen. So now that we have this, we can simplify this a little bit more. X du dx is equal to u minus 4 minus u squared over 1 minus u. Oh, this is plus u squared. Yep. Okay, so now you'll notice, oh, this can be simplified even more. Wow, okay, so x du dx, yeah, those u's will simplify, they'll cancel. These u's right here will cancel. Bam. And then we're left with u squared minus 4 over 1 minus u. Okay. So now this is separable. See, we made it separable. So now we just have to separate it. So I'm going to multiply, well actually, what I'm going to do, this is a little weird. You'll notice how this separable equation is a little weird. So what I'm going to do is I'm going to multiply both sides by dx. So du, so x du is equal to u squared minus 4 over 1 minus u dx. I'm now going to multiply both sides by 1 minus u. Actually, before I do that, let me get all the x's over to the right side. So let me do this all in one step. We'll have du, I'm going to multiply both sides by 1 minus u, divide both sides by u squared minus 4. So now we have this side. And then, we don't need this parentheses. And then for this side, we just divide by x. You see how I did that? So now that we're here, we can directly integrate these two sides, just like how we did in the last video. Now we have a separable equation, and now we just solve it the same way we solved the other ones. Right? So, let's see. If I integrate this left side, we're left with we unfortunately we have to do, it looks like we have to do what's it called? we have to do partial fraction decomp on the left side, right? So I'm going to rewrite the left side. So we have 1 minus u. This is something you should have learned in Calc 2, right? So u squared minus u. This is equal to a over u minus 2 plus b over u plus 2. Oh, this is a 4, right? All I did was I split up this bottom part. I should rewrite this. Hold on. This is u minus 2 times u plus 2. And to simplify this, I'm left with 1 minus u is equal to a times u plus 2 plus b times u minus 2, right? All I did was multiply both sides by this. Okay, now we have to solve. I'm going to distribute the a and b, so 1 minus u is equal to au plus 2a plus bu minus 2b. We set both sides equal to each other, so let's look at the u's first. So we have the u's here, and then we have these here, right? So now we're going to have two equations. So we're going to have, let me do two different colors. We have 1 is equal to 2a minus 2b, and we have negative u is equal to a times u plus b times u. If I rearrange, actually, you don't, when you rewrite this, you don't include the u's. You only include the coefficients. That's my fault. So it's just this. And now, I'm going to take this one to solve it for a. Let's solve it for a. A would be equal to b minus 1, well, negative b minus 1. If I plug it in over here, let me do this in black. If I solve this for a, we have negative 1 minus b. I plug it in over here, I get 1 is equal to 2 times negative 1 minus b minus 2b. That's 1 is equal to negative 2 minus 2b minus 2b. 1 equals negative 2 minus 4b. That's 3 is equal to negative 4b. So then b is equal to negative 3/4. Right? And now that we know this, I'm going to plug this back into here, and we get a is equal to negative 1 minus plus 3/4. So then a would be, this would be negative 4 over 4 plus 3/4. So then a is equal to negative 1/4. Yep. So this is our a, this is our b, our a and b. Now we plug it back in up here. So let me zoom out. We have the integral of negative 1/4 over u minus 2 plus, let me write it like this. Let me separate these integrals. I'm gonna pull the minus sign out from the 3/4, and we're gonna have minus the integral 3/4 over u plus 2. I'm gonna set this equal to the integral of 1 over x dx. Okay, so now this is where we're at. Let me move that down. Okay, so the right side is a very easy integration, but the left side is a little tougher. So this is a pretty hard example, by the way. So we can pull out, let me think about this. Oh, this would just be negative 1/4 the natural log of u minus 2, right? Minus 3/4 the natural log of absolute value u plus 2. And this is just the natural log absolute value x. Now remember, on the left side we had c1, on the right side we had c2. That's just going to become c, just like in the previous video. So for example, we had plus c1 plus c2, c1, let me do this in red. We had plus c1 plus c2. If I rewrite the whole thing, I'm going to do c2 minus c1 is equal to c, and we get plus c over here. So now this is the final answer. Well, no, it's not actually, because you notice that we have u and x. We need to turn this. We need y. Right? Now if I scroll back up and we look back at what we made our u is y over x, right? That's how it is for every homogeneous equation. U is always y over x. So we know u is y over x, negative 1/4, and this is from before. So we have negative 1/4 natural log y over x minus 2 minus 3/4 natural log y over x plus 2 is equal to the natural log of x plus c. Yep. Okay. This is technically... Okay, so now what we want to do is we could leave it like this, but I'm going to show you how to simplify this. I think it's a really good idea to simplify this. It's not too bad to simplify this. So what we can do is I'm going to multiply, I'm going to multiply the whole thing by 4. Right? Let me just make sure. I'm going to multiply the whole thing by negative 4 actually. So we'll be left with ln. If I multiply the whole thing by negative 4, this will become plus 3. Right? And this would become negative 4 ln x plus c. So now we can do some log rules here. This will stay as this. This, whenever you have a number multiplied by a natural log, you can take the inside of the natural log and raise it to the third, like raise it to that number, raise it to its coefficient. And then you're going to have, do the same thing over here. ln of x to the negative 4th plus c. Okay, so now... Oh, wait a minute. You know what I forgot? I forgot to multiply the negative 4 on the c here. This is actually very important, because this term right here is a new constant. It's still a constant. It's still going to become a constant, but it's going to be a new constant. So now what we can do here is on the left side, if we ever have an addition of logs, right? You know that is multiplication, right? Like if you ever have like a natural log of x plus the natural log of y, for example, that's just ln of x times y, right? So I'm going to use this rule on this side. That's the natural log y over x minus 2 times y over x plus 2 cubed is equal to natural log x to the negative 4th plus c, sorry, minus 4c. You know what? I will call this our new constant now. This is a new constant k. So this is our new constant now. Okay? So now what I can do is I'm going to exponentiate both sides to get rid of the natural logs. So if I exponentiate both sides, I'm left with y over x minus 2 times y over x plus 2 cubed is equal to x to the negative 4th times k, right? Just like in our integrating factors video, if we have e to the ln, let me do this, a little side note, e to the ln of x to the negative 4th plus k was k, because you can rewrite it as e to the ln x to the minus 4th times e to the k. And this is a new actually, to avoid confusion, you may have just gotten confused by the k. I'm not going to rewrite this as a new constant just yet. I'm going to keep it at like that for now. I'm going to keep it like that. So now this becomes a new constant, k. Just to avoid confusion, we're going to plug this in right there. Okay? And we know this just becomes x to the negative 4th because we exponentiated that natural log. Okay, now that we have this, we're not done yet. We can solve this for just for k. We can simplify it even further. So if I can simplify these two terms right here. This would become, this is y, if we multiply x by the negative 2, that's y minus 2x over x. And then we're left with y plus 2x over x cubed is equal to k over x to the 4th, right? Now, if I multiply the left side by x to the 4th, this will leave me with, this is a very weird trick, I will say this, but think of this as to the first, think of this as to the third. If you add those together, we're going to have to the 4th, right? So now from this point on, you're able to just cancel out the denominators here with this term over here. So then we're just left with, I'm going to be completely honest with you. I'm not entirely sure how this works, but this is how I've always thought of it. It's how I've always done it. And when we're here, don't forget your absolute values. That's very important that you keep them there. Yeah, my professor never really explained what happened here. He just kind of did it. And it always works. It's weird. Like if you have like the x to the negative fourth on the right side and you multiply it over, all that's going to happen, like as long as these exponents add up to 4, those denominators will just cancel. They'll just disappear. Not too sure what goes on there, but it works. And then this right here, this is our answer. That was a very long example. Very long example. So you can see this is how you would do a non-separable homogeneous equation. I'm going to do another video with a few more examples of homogeneous equations just to help you guys out, because I know this was very long. This is a long video. So I'll leave this one here and I'll make a separate video for some more examples.